Welcome to Cloud Native Now 2023. I am going to talk a little bit about what we are doing in the university, some project that I want to show you. So my topic is Usactar Soccer World Cup real-time system with Linkerd and Kubernetes. A little bit about me. Well, I am a systems engineer. I am from Guatemala. I am an operating system professor at the public university here, USAC. I am also a Cloud Native Guatemala organizer meetup. I work as a DevOps engineer at Yalo. I'm also a Linkerd ambassador and a CNCF ambassador. And I am the author of Edge Computing Systems with Kubernetes book with Bhakti editorial. Let's see a little bit about my university. This is how it looks. This is my university at Guatemala. A little bit of my students, an old picture here, old photo with my students teaching there. I was doing like a test in that moment. Because let's say that in our country in Guatemala, like we don't have like a lot of resources in the university and most in the public university to spend in technology or experiments on in the laboratories. So we can take advantage about the freedom of using open source software. In this way, we can create like pretty awesome projects without using or paying zero or consuming something that we don't have like, or something that could be so expensive to use to create projects. So we are getting advantage of open source. My course in the university, in the engineering faculty, is like operating systems course. I teach, distributed systems, processes, the basics of operating systems, virtualization, concurrent programming, that kind of stuff. That's the content of my course. To have a little bit of context about Cloud Native, this project uses Cloud Native technologies, but as you know, there are like four main topics around Cloud Native, like could be like CI/CD, containers, that maybe the technologies use APIs, the 12-factor apps and that things around. So we use Cloud Native technologies, the ones that empowers organizations to build scalable applications that use public and private clouds, containers, service meshes, microservices, and a lot of things. That's all the things that Cloud Native means, the technologies around that, and how the application is structured. But let me explain you about my project. Well, I am the professor of that course, so let me explain you that. The project is called Usactar. Well, this Usactar is like a fictitious name, doesn't exist. It's more based on the past Qatar World Soccer Cup. It's based on that. The idea is to create a real-time system that gets some information about the different soccer matches, how I can simulate that predictions, get information around this tournament. So that's the idea, create a real-time system. But we are going to use Kubernetes and the concepts of distributed systems, concurrent programming, and that kind of stuff. The main goal, as I mentioned, is to create a distributed system where the students can explore new technologies, learn Cloud Native technologies during this process of working on the project. The technologies, as I mentioned, use open source Cloud Native technologies, the ones that are around the CNCF ecosystem. Let's say that CNCF this organization looks for the Cloud Native technologies around in a specific Kubernetes and technologies that run around Kubernetes. But what kind of technologies we are using in our project around the CNCF ecosystem? Of course, we are using Kubernetes, but let me explain you this one. In this slide, you are going to look like not a copy-paste information. It's more like what the students can understand in an easier way. So Kubernetes could be like our platform to create the distributed system. So we are not using Kubernetes as a tool to implement CI/CD pipelines or that kind of stuff. We are looking to Kubernetes to create a distributed system. how to scale a system. So we are using Kubernetes, use their declarative definitions to create our software running on the cluster. We are using gRPC. As some of you could remember that maybe you learned about how the process communicate inside the computer and that things was like an old style of communication called RPC. So gRPC is more like a kind of evolution and a modern word that evolves from RPC communication in the old days, let's say. So we are using gRPC as a way to communicate containers and pods and that kind of things. We are using, of course, Docker. Let's say that we're turning a little bit here, like Docker is our way to create like a small piece of software that is running. But Docker explains you like, or gives you the ability to create like a kind of virtual environment that you can use. And Kubernetes, let's say, let me give you this example. It's more like, let's say that you have an orchestra and you have different musicians. So these musicians play a specific instrument like a hornet or something like that. But you have to organize all the musicians in order to hear a beautiful and a harmony in the song. So you need an orchestrator to organize that musicians. So Kubernetes is the orchestrator. Let's call it the orchestrator. So Kubernetes is going to organize the musician in order to play the song. If they need more musicians, Kubernetes is going to add more musicians or reduce the quantity of musicians. So that's Kubernetes and Docker around. So the students are going to learn about it. As I was mentioned, well, gRPC will be like our own way to communicate the processes around the network. A pretty fast way to communicate. Linkerd will be another concept, like using a service mesh, a way to interact with the networking traffic and do something around this traffic, like maybe communicate multi-clusters, get some observability or some metrics around the golden metrics, like requests per second, success rate, and that kind of stuff. So Linkerd is going to help us with that, and the students are going to learn around it. Locus is a simple tool to perform traffic load testing. So Locus is more Python oriented. So you are going to create like a kind of script around using Python, and you are going to create that load test with Python. So Locus is really, really nice. It's also open source. Because let's say when you are learning concurrent programming or operating systems, you are going to tackle a little bit with queue messages and how to manage messages and that kind of stuff. So Stringy could be like an easy way to install Kafka. That is a software that can manage messages and that kind of stuff. So Stringy is a Kubernetes operator that you can use to install Kafka in your cluster in an easier way. So for the students, that's great to simplify their lives. And the last piece is the NoSQL databases, because they are like the last thing or the new kind of stuff that right now is revolutioning databases. We are using two kind of databases here, MongoDB as the document-oriented database, and the Redis a key value database, in order to get information, get some metrics and everything. And because it's a real-time system, NoSQL has their own space here. That's the reason to choose Mongo and Redis here. I want to clarify that this project is more like just an experimentation stuff to learn new technologies and concepts around cloud native and distributed systems. So for this project, I also love that the students can play with cloud providers, but the problem could be like, I don't have budget to spend on cloud providers. So we choose Google Cloud because give us like free credits to play around in our project. And Azure has a small trial, but it's enough to be used in our project that consists in 2 clusters in different providers. So as I mentioned, no money. So we use that free credits from the cloud providers. That's the reason to don't use right now AWS, because it doesn't have like a kind of free tier on the EKS service. Or at least it's too expensive for us. Well, so let's move to the distributed system design, how it's organized. The last year, this was like the original project, a little bit more complicated than the project that we are working right now. So let's move to the new evolution of this project. So something that is pretty interesting, I was working on the project by myself, get my hands dirty on this project. So what happens? I took this project and I got a kind of evolution here. This is the new way to create our project. It's more simplified, more basic concepts, and more easy to learn these new technologies. So let me explain you what is this project about. We have 2 clusters, the Kubernetes cluster on Google Cloud. In the left side, in the right side are the services around Microsoft. We are basically using Kubernetes, AKS, Azure cluster, and how it works. Let's say that there is a user in the step 1 that is performing some network traffic or simulating that somebody or a lot of users are writing to the system. So Locus is going to create this load testing simulation and is going to be received by a load balancer in our Google cluster. And this load balancer is forward the traffic to an REST API made using Go. This REST API is going to get the information and is going to push the information on a Kafka queue called matches. Yeah. So we are going to produce with this event information that a queue or a topic in Kafka is going to receive. In the step number 2, in the step number 3 is going to be another service that is going to be listened to the topic match. Every time that this topic is going to receive the information, there be a consumer made with Go, a Kafka consumer that is going to read the information here and is going to send the information using the gRPC protocol, let's say, or that is going to be our way to send information. This gRPC client that is going to send the information captured inside this topic queue on Kafka is going to get information and it's going to send information to a gRPC server in the other cluster. But it's going in Kubernetes is going to mirror this service in the other cluster as we are working in the same cluster. So they are like a multi-cluster connection there. So it's going to send information to this gRPC server, and finally, this gRPC server is going to insert the data on Redis. In parallel, it's going to send information to MongoDB2, like a log information, and finally, in the step number 7, this maybe the same client or the student is going to check the Grafana dashboard that is going to check the information about Redis, right? So that's basically how the project was structured. Summarizing, send information with Locus, an API REST is going to receive the information, is going to put information in the topic. Another service is going to get the information from this topic and is going to send the information using gRPC to the other service in the other cluster. Like the other service lives in the same cluster using that mirroring service that Linkerd gives us. At the same time, it's going to send information to MongoDB. And finally, we are going to show the information in a Grafana dashboard, querying the information inside Redis. So less is more, because the previous project was like more complicated. using like different managed cloud provider service like Cloud Run and that kind of stuff. Here, I want to mention that I am using the managed service Cosmos DB. That is an Azure service that deploys a MongoDB service and Redis cache. That is basically a managed service of Redis on Azure. So less is more. So the summary, what the students are going to learn in this project. Let's list what they are going to learn. Containers. They are going to learn containers, Docker, distribute systems with Kubernetes. They are going to learn how the process communication in the network using gRPC and Go programming, or the Go programming language, Kafka message queues, service meshes, and multi-cluster communication using a service mesh, in this case, Linkerd because it's pretty easy to use, and NoSQL databases. And load testing using Locust. So right now, well, let's go a walkthrough around our Usactar project. Okay, Locust is running right now. Here is the GitHub repository that contains all the command lines or the CLI command lines that I am using here to run my stuff. So the first step is run Locust to simulate the traffic. So once you have Locust, it's going to open you a dashboard with this information. How many users, how many concurrent users, let's say, and an endpoint. This endpoint is part of the services of Kubernetes. Is this endpoint that exposes the public API that is going to receive the information. And let's start with the traffic simulation. Let me show you something here. Let me see. Okay, here I have like the live log, let's say. In this side is the log of the API. In this side is the service that is consuming the or receiving the REST API information and is going to insert in the Kafka queue and is going to send information using gRPC, and this one is going to receive the information in the other cluster, right? So let's run the simulation part. So right now it's like sending information. As you can see, this thing is receiving the information. And here is a Grafana dashboard that is changing on real time about the information that it's receiving. Here are the different matches that is like getting right now on real time. How many matches are right now? The messages processed to receive this information. And another way to show this pie chart, but using some bar chart, let's say. So right now, it's like receiving all the information using Locust. And the cool stuff is like you can see the information in real time. Well, the big challenge here is like you can simulate like hundreds of users at the same time, but because of demo purposes, I am going to limit that simulation to a simulation not too heavy for my platform right now, but that's the goal of my platform, let's say. So as you can see, Locust is doing its work right now. It's like sending information, and you can see some charts about how this thing is sending information and how the different services are receiving the information here, and how the Grafana dashboard is like showing the information on real time. So it's like a kind of maybe a little bit complicated to understand how it's going to work. Locus receiving is sending the traffic to one cluster that has some service that puts the information of Kafka. So let's say that the system doesn't have the enough capacity to read the information. So in order, or depending on the capacity of the pod to read the information inside the topic, is going to process the information. For example, if I stop the Kafka queue, this thing is going to still receiving the information because has some kind of lag or delay to process the information. Because they have like a lot of messages there, but you have to process asynchronously, let's say, and there is some delay on that information. But it's like showing close to real time the information that is being processed. In the Mongo side, you can see how many messages are processed here. And let's say, for example, right now there are 161 messages here, and it's going to be still refreshed. Because some of the evaluation that I am doing right now, some messages generated are discarded. So maybe it's not like sometimes the same information about the information that is granting on Mongo just for log purposes, let's say, could be like more or less pretty similar than the information that is shown here in the Grafana dashboard. And some data is discarded because of prevent duplicate matches, let's say, between Qatar, BS, Qatar, and that doesn't make sense, right? So I am like removing duplicated or invalid kind of matches here. So let me show you a little bit the code, or let's continue with the simulation. Maybe let's add a little bit the concurrence on the system. So you are going to still watch how the information is processed, right? And you are going to reflect the change here in the matches, right? So this is how the things are moving here. So let me show you the code a little bit. So we have like, well, we have YAML configuration, the API. We have like the consumer configuration. One for the, some of the deployments are configured on Azure and another ones on Google, right? The consumer, how I implemented the Grafana dashboard. I am using the Redis plugin to read information on Redis. So you can see here, for example, if I edit the dashboard, is going to check this teams counter variable using the hgetAll command on Redis. And I have like different kind of values that I am querying on the dashboards. For example, I am querying here the messages, and it's going to show this thing on almost in real time, right? So another thing is like, well, the code, the deployments, and everything that I have here, the Go code here, the locus configuration to simulate the matches on Python. So I just Go and Python, and the consumer of Kafka, all the code in this repository, and also the, let me see, the gRPC server, the gRPC server code that is going to insert the things on Redis, right? So all the things that you can see here, all the code is in the repository, and you can experiment a little bit with it. And finally, let me show you the Linkerd dashboard. So Linkerd is going to show you Now, how the information is moving, like the success rate, the latency, and the request per second. It's not like too much. You can also install the Grafana plugin for this to get the information, and it's going to show. You can also take a look. As you can see, this information is changing on real time. You can use Grafana to visualize that information, and you can also use the Linkerd CLI. So that's in general how the project works, and the challenge for the students to learn new technologies, but they are going to experiment, like create like architecture, how concurrent systems like social networks are working inside. To end my presentation, I'm going to invite like people from Latin America. Well, I speak Spanish. I want to invite the people that speak Spanish to Cloud Native Guatemala, part of the CNCF groups, the links of the community that we created there. And we are like hosting the KC Guatemala, that is a event around Kubernetes, but it's hosted locally in Guatemala. It's going to be online, and one day online, and the second one will be a hybrid event. So you can access to http kcdgt.com. You can register there. It's for free. And well, because I wrote a book, here is the link. If you want to explore my book a little bit, it's like explaining distributed systems, but oriented to edge computing applications, and using Kubernetes and running Kubernetes at the edge. Let's say Kubernetes inside a Raspberry Pi. The repository of this demo is this one, Cloud Native Now 2023. The repository that we use in the university, maybe if you want to contribute around this project or give ideas or to share different projects between universities, maybe you can contact me on this repository creating an issue, or maybe you can contact me on social networks. The slides of this presentation are here. And well, my personal contact is like Sergio ARM GPL on Twitter, my website. And you can also check, let's say, on LinkedIn, Sergio Méndez, and whatever social network that you have. So thank you very much for this opportunity. And that was my presentation called Usactar Soccer World Cup Real-Time System with Linkerd and Kubernetes. So thank you very much.